Logarithms are very useful, especially if it comes to the problems like these, when the exponent contains unknown. In my case, we have x and x. We have to find value of this unknown. We're supposed to apply a logarithm to both sides of the equation. Someone is going to ask, what logarithm? The answer is common logarithm or natural logarithm. Someone is going to ask why. Because our calculators operate with natural logarithms or common logarithm. So, I'm going to use the common logarithm for this problem. Question is why? Let me show you. I have logarithm 10 to x is equal logarithm 12. I want to find value of x. I have to use the property for the log of power in order to bring this x to the front of the logarithm. And this is going to be my coefficient, x log of 10 is equal log of 12. Please notice that the common logarithm has base 10. This is invisible base 10. Next, we're supposed to use the property for the log of 1. I mean, when the base is equal to the domain. Log with the base equal to domain is equal 1. That's why I'm going to write x times 1 is equal logarithm 12. This is why I use the common logarithm, because common logarithm is going to simplify my problem to having just 1 multiplied by x. 1 times x is equal x, and this is equal logarithm of 12. In order to find value of x, you're supposed to use the calculator. Simply type logarithm 12 and press answer. You're supposed to get the answer 1.0791. And this is the solution to the problem. If you want to prove that this is true, again, you're supposed to use the calculator and simply find how much is 10 to power 1.0791. It has to be approximately 12. On my calculator, this is equal 11.99 and some change, so we can say this is equal 12. So x equals 1.0791 is the solution to my problem. Let's take a look at the second example. Again, I have x in the exponent. I have to find the value of x. So I have to apply the logarithms to both sides of my equation. I can use either log, natural log or common log. Why? Because the base of my exponent is different than 10 and is different than e. That's why I can use either one. I'm going to use common log again. I have logarithm 3 to power 6x equals logarithm of 5. Next, I'm supposed to use the property for the log of power. And my exponent is going to be, this time, the coefficient. And I'm going to have 6x log of 3 is equal log of 5. In order to find value of x, I have to divide both sides equation by everything wherever is multiplied to x. So I have to divide both sides by 6 log of 3. 6 log of 3. Log of 3 and log of 3 will cancel out. 6 and 6 will cancel out. X is equal logarithm of 5 over, open parenthesis, 6 logarithm of 3. Please keep in mind that anytime you are going to have more than one term in the denominator, and doesn't matter what operation you are going to perform, addition, subtraction, multiplication, or division, you're supposed to always use the parentheses. Otherwise, your calculator is going to divide log 5 by 6 and everything multiply by log of 3. If you are going to add the parentheses, calculator is going to divide log of 5 by 6 log of 3. If you are going to plug in these values into the calculator and divide them and multiply, you will get the answer. X equals 0.2441, and this is the solution to your problem. If you want to verify your answer, you can apply this value instead of x into the original equation. Simply write 3, open parenthesis, 6 times 0.2441, and this has to be approximately 5. So this is the solution to my problem.